Okay, in this video I'm going to do a signal-to-noise ratio problem. And it gives us the SNR value in decibel units. It gives us the signal value in dBm. And it asks for the noise in dBm. Then it asks for the signal and noise, the SNR, as a ratio rather than a decibel quantity. And these calculations are straightforward. What I'm going to do is write down the equation that the SNR in dB units is the signal power in dBm units minus the noise power in dBm units. We might also write instead P signal minus P noise and put dBm here to remind us. Okay. In any case, it's the signal minus the noise. And they're asking for us to solve for the noise. And so I've got to solve this equation for P noise. I'm just going to call it N. So N in dBm, the noise power, is the signal power minus SNR in dB. If you need to take this equation above off onto a separate piece of paper and add the noise power to both sides of the equation, then subtract the SNR from both sides of the equation, and you'll have isolated the noise power on the left-hand side. In any case, I can plug in now. Signal power is minus 5, minus the SNR, which is 40, and so I end up at negative 45 dB as the signal to noise. This is the noise power, minus 45 dBm. And you can envision this as sort of a signal and a noise, and the distance between the two is the SNR. So it's a lot like a loss budgeting problem, but here instead of the loss ratio of the input power to the output power, we've got ratio signal to the noise. And then we've got plenty of room to calculate the SNR as a ratio. Is 10 raised to the SNR in dB units divided by 10. And this is 10 raised to the 40 tenths, 10 to the 4th. So it's 1E4 or 10,000. Don't need a calculator for that one. Okay, so this is an example of a signal and noise ratio problem. Very similar to a simple loss budgeting problem, except I'm using signal power and noise power instead of input power and output power. Okay, hope this one helps on this problem. Thanks for listening.